entire event, not only today's, but the whole week has been really productive. And I'm sure that today what he is going to tell us is going to provide us the roadmap, what is likely to happen now. So we all listen to him, and I don't want to be between you and Somnath much. Dr. Somnath, the floor is yours.
It would be nice that we can sit there.
Yeah, I will sit there because you have some.
Can I get the lights a bit dim or switched off? Yeah. So good evening. I'm really honored to be here in India International Center, and also to speak to such a galaxy of eminent people here who already know quite a bit about what the subject which I am going to speak, and also have a very learned opinion about how we should proceed, work, contribute, etc. So what I thought that I should speak today through a PowerPoint presentation, though it was not the intention to put a PowerPoint first, but then there is an opportunity to put it. It will be better that you can have some color in the speech, which I suppose I don't make it in my words, then there will be color on the screen. So that's what I thought. So I'll put a PowerPoint and quickly run through them. There are about 40 slides, but then many of them I won't be dwelling on it, so it won't cause much problem for your eyes. So first, the theme of my talk is the transformation of the Indian space sector and the expansion of space enterprise of India, which I would like to coin like that now. I would like to coin it as a space enterprise of India. It's not the Indian Space Research Organization or Department of Space any longer. The actors who are there in the space sector now, they are going to come together to create the space enterprise. It will consist of many actors. The Department of Space will be empowering this to happen. This is the vision, and this is the transformation we look at in space sector. So of course we know the space program has been created as a people-centric, application-driven space program, having many verticals, right from the need, the requirement. From there it started. The delivery of the space application to the public, to the common good, was the whole theme for which we created the applications, we created the instruments, then the satellites, then the launch vehicle, and all the entire infrastructure came about through that thought process, that idea, which is very unique to India, which was not the case. Maybe recently there are some nations who are doing it in that direction. So let me go straight to the vision and the Indian space program, its beginning, its growth. I think these slides are well known to all of you. I won't dwell on it. Started with the vision and the magnetic personality of these men who created the space program in the troubled times, give a structure later by Satish Dhawan, and that we have the organization which is able to do the end-to-end solutions through space sector today. And we call them now verticals. We call them verticals because we have the space transportation vertical, we have the space infrastructure vertical, which is nothing but the satellites and the services it gives. We also have the space application vertical, which is nothing but the delivery of the products from the space. We have the human space flight vertical today, which we started as a Gaganyaan program. Also, we have a vertical called the capacity building, which is definitely needed for sustaining many of those activities. And if you look at a glance what we have in space today, we have accomplished over the years in terms numbers of launches, a number of launch vehicles, satellites, and also technology missions, the science missions, the commercial accomplishment in terms of the launching, etc., etc. They're summarized in this slide. I am not going to read them. But the most important thing which I believe is that launch vehicle fleets that we have created by the PSLV, GSLV, and GSLV-M3, which gives us indigenous capability to build them and launch them from our own soil. The ability to build a satellite, if you want, you can really build it in India today. Of course, there are some import content in satellites. You know, the electronics continue to be remaining important. We also did quite a bit of technology demonstrations. Mostly, you may not be knowing them in public, what exactly are the technology developments that are happening, but only to know that we have done human spaceflight, space class recovery, air breathing engines, reusable rockets. Many of times, this information come in bits and pieces in the public. And also we did exploratory missions starting from the Chandrayaan-1. Of course, there were a lot of questions when we started this program. Why at all you do space exploration and what is the benefit to our country, where debates and questions were there. But of course, there was enough support from government and public on this. Chandrayaan 1, the Mangalyaan, and the the Astrosat are one of the three of those very important missions that we did, and we are going to continue this process with a shoestring, very limited budget to do such activities. Looking at the communication sector, we are really self-reliant today. Of course, we are leasing some transponders from many of our service providers in Indian continue to provide services for the sectors which requires them. But we continue to be one of the important service providers for meeting all the national needs for communication, and this is growing through various transponder lease support services as well as high throughput, which are now come to stay. In the future, we are going to build many more of the communication satellites. One of the recent one which we launched was a GSAT 24 through a demand-driven approach that was done for telecom services through NSIL. The Earth observation capability was one of the pioneering work that we did in the space sector, starting from the early remote sensing satellites. And there was in the discussion, somebody was mentioning our images were one of the best in once upon a time. And we were the pioneers in introducing CMOS technology in Earth observation. And the data of remote sensing satellites were relayed to various nations on a commercial basis. But this business has largely come down in Indian context, and we have not been doing large number of remote sensing satellites and replacing them in regular interval in the last many years. This is one weakness, I must tell you. But we have been growing in terms of capability in remote sensing, in terms of the spectral, the temporal, as well as resolution point of view. And we have now having satellites, enough number of satellites to support certain sectors, including our strategic sectors. But this area requires great attention in the days to come. We have been growing in terms of satellite building from 1980 to today in various ways. The INSAT series was one of the classic example how we combined communication with Earth observation. For example, in the area of meteorology, we have been able to provide services. Also building capability in the satellites, mostly in indigenous capability. We have started it as an indigenous capability, but at some point in time, technology was changing. We went outside, got some technology to build a higher next generation satellites, and this process was continuing. And we now are at the thresholds of looking at future generational satellites, which are going to be more optimum in mass and meeting demands of the communication industry in terms of high throughput. So we have been successful in making some of the satellites, but there are many challenges in this, including introduction of electric propulsion system to bring down the mass, to bring down the launch cost, and also to provide services at a cheaper rate as we discuss it today. But these are something which we need to address. And we are heavily dependent still on imports of elements which actually affects our overall schedule of realization of satellites. This continues to be a major challenge. Look at the space application sector in ISRO. This has been one of the hallmark of the space program. The application continue to remain very important for sustainable development, for supporting the economic activity. Disaster reduction has been very, very important. I think there we have done very, very well in terms of delivering services. Governance has been very important in terms of decision support through the flagship programs of the government. And for this, the remote sensing data has been well utilized. Asset mapping and management has been very well handled, and through various paths, so various geoportals, information services, working with ministries. This has been one of the important role that Department of Space played over the years. Remember that Prime Minister Modi himself took a review. As soon as he took the first prime ministerial opportunity itself, he called all the ministries and all departments and connected with ISRO to develop programs for all ministries. And this has been really important for us to drive the application of space sector in every ministry department area. I'm not going into each of this because that's not really the scope of that discussion and talk today. But I will quickly go through some of the important domains where the application has really made inroads and made some impact. This is what I would like to tell you. Of course, Dr. Shailesh Nayak is here, and he is very familiar with the topic, the slide which I have put on the potential fishing zones, where the data from satellite has been helping in terms of the fish catch and the type of benefit. He also elaborated today in our discussion how the satellite data in terms of the ocean color as well as ocean surface temperature has been helping to make the prediction of the fish schools and thus save money for fishermen who wander around the sea for in want of the fish. This has been really a success story. Another important success story is in terms of spacecraft data is in terms of pre-harvest and post-harvest predictions for acreage estimation, the crop estimate, and today this area is now slowly becoming into the commercial and business opportunity. One of the example which I want to tell you today is that one company in Bangalore called Satsua, they are into remote sensing data based banking support system for agricultural lending. So somebody who wants to lend to take money from banks, the banks immediately approach this company and they do the real survey of the land which the farmer is having. He makes an estimate of what type of return on investment he will get, and the entire intelligence for that particular lending is passed on to the bank in 15 minutes. And the bank can make a decision on whether to lend or not to lend within no time. And this has actually transformed the lending process for agriculture sector, and the company is very, very successful, and they are looking into building satellites on their own today. They are in Bangalore. So though these are developed as applications for governmental departments today, the offtake from this is that there is a possibility for business and commercial activity now present for future. I think this is something which I want to tell you. And we have also demonstrated technologically that you can look at different crops, and up to 16 crops have been now capable today, and we are able to do the institutionalize this whole process through the Ministry of Agriculture, through the Mahal Nomas Center for Crop Forecasting, and this is now operational. And they are trying to do many more things in the recent times, which I have discussion with them, is in terms of crop insurance. I think this is a very big business today, something like they estimate is something like 50,000 crores. Another domain, the area where we have been working is in terms of drinking water and sanitation, where the groundwater prospecting, quality and sustainability has been one of the important achievement of space sector, where using satellite data, there has been sufficient maps prepared for the entire country where there is a groundwater prospecting is possible. And you don't have to go on drilling wells where there you won't find water. Using this data, there is a possibility that you will end up with a successful result of the drilling, much better than that you could achieve without this data. So this is one services that we are providing through the ministry. Similarly, for the surface water also, here the issue is in terms of the time the surface water conditions change, and the whole data in terms of the water bodies, and number of water bodies in this country are so huge, and if you want to count the number, it's there in few tens of lakhs of water bodies, and they have been mapped today to an extent that you can look at the variation with the time, whether they are still preserved, they are going, and how the water comes. You can even look at the structures and then help preserve these water bodies using the for the local administration. They can use it for drinking water or for aquaculture and various other activities. Those is some information that is available for decision makers. Similarly, the irrigation infrastructure monitoring has been one of the important domain where satellite data has been well utilized, like the building the structures for water collection, saving, preservation to handle drought, the canal structures, dams, mini dams, etc. So all these are done as part of the projects that ISRO undertake with the different ministries and departments and states, and we execute this project for the support of those governments and ministries, and various accomplishments that are listed here, which I don't want to go through at this moment. But the satellite data has been one of the important domain through which you can do these type of things. If you just imagine that you want to go around and walk and then find out this detail and then really create a survey data, it's really impossible for this country. Only through satellite data that you can do this. And the challenge today is that these are changing with times, and our ability to continue the mapping and update in a periodic manner is the biggest. One time you can do that, but then how fast you can do, how frequent you can do, can you do it in every month, every year? This is a question that we are addressing today, and for this we need more number of satellites. We need to have the more funding to continue this process. These are the challenges that we are facing in this area. The recent one, one of the important the inputs that we started providing is for energy segment. For example, if you want to put your solar plant on top of your house, you can go through this data, which is available as a solar calculator, and estimate what's the type of yield that you can get for a local location. You give the lat long data of your place, and you can estimate through this application whether it is a good place to put your solar plant or not. So this is also a satellite based data which looks at the insolation with the time, and you can actually estimate what will be the yearly yield that you will get if you put a solar plant at one given location using precisely that satellite data which you can be trustworthy. Monitoring of the natural resources has been one of the important goals that satellite has been doing in terms of the land use, land cover, forestry, wetlands, snow, biodiversity, forest biomass. All these are very important topics. I think carbon footprint, the carbon ingestion and wastelands continue to remain as the hot topics for various reasons that I don't want to discuss. The land degradation studies, the desertification and reclamation, all this becomes important, and along with satellite data, there are equally the ground-based observations and networks. Our scientists are working to create this amalgamation of all this data for providing to the government. Another area is air quality indices, which are also estimated. Here, R&D is still on. I don't think that satellite data is still fully reliable. Of course, it is connected by the ground-based observations and satellite observations. We can look at how the air quality indices can be provided to various cities, and you are getting it in your mobiles now recently. It must be coming from various other satellite data as well. Geospatial support governance has been very important for us, because through this that we get certain projects, and we continue to support all the flagship programs of the government. For example, if you look at the food security missions, the crop insurance, irrigation, Amrit, that citizen-friendly sustainable cities, Manrega we have been supporting is basically, Manrega we support through the geospatial mapping and also mobile applications to upload whatever work you do on a given location. So you can, the structures you build, or a road or a canal you build, the photos can be taken, you can upload to the Bhuvan. So it becomes a database creation. And this is connected to the geospatial information system. So it becomes the information so that you can tweak the data so that next year also you get the money for the same work you did, because in the rain the whole thing will go away. So you can't do this type of things any longer if you really connect through the work that you did and connect to a geospatial information system. You can do much more monitoring, which is very reliable. So this is one task, and there are many similar tasks which I am not going to dwell upon. Recently, when the COVID came, similar this GIS database and the connect to various activities have taken up by different centers of ISRO, and we could do for release a COVID-19 dashboard. We could also identify through the Bhuvan portal and geospatial information the vaccination centers, containment areas, identification, and many mobile applications came out of this, and many of this work happened in some states very vigorously, and some states didn't work also. So I must admit, it all depends on the local administration and their support and various local situations. But then generally the space-based solutions were really available for somebody who really need it. I think this is the message we want to do, and through this we can do, when there a pandemic comes, we can develop applications to support this. So though it couldn't be done in very short span of time, I think the impact may not be very large, but it was used by certain districts and states very effectively, I must tell that. Coming to disaster risk reduction, I think this is very, very important for you, especially cyclones. I think all those who have really faced a cyclone and really saw the impact, I think they will appreciate this. But for us who are in the comfort zones are never going to tell this. So you must at least once go to a place where there has been a cyclone hit and then understand what it is. So and we continuously monitor this especially on the eastern coast. Now it comes in the western coast as well. Occasionally now the number of cyclones in Indian Ocean as well as in Arabian Sea is actually increasing in terms of intensities and numbers. This is very important for us because the track prediction and the accuracy of the prediction of the track has substantially improved over the years. And I can tell you that compared to years back where there has been large displacements of people and death also, the number of casualty due to cyclone and other natural disasters has substantially come down precisely due to the satellite imagery and the prediction methodology that we have today to predict where the landfall will happen, what extent the dangers are there, and this is very well reliably used by many states who are actually getting affected, and we are giving advisories to these states for such conditions. And all this data we will have to send through various means. For example, satellite data comes, but then ground in the district administration or a village panchayat who will actually have this information to act on it. I think this becomes a very important issue. And for this, what we have done is to create geo portals. I think this is what I want to tell you, that we have been working on various geo portals to disseminate this information. And Bhuvan, I think for those who are not familiar with this, I advise you to search on Bhuvan and then go and see Bhuvan and understand what it is. And it is constructed for not for general public. It is actually created for governmental use and institutional uses, where it is actually licensed, and huge amount of data is available for administration to take action and to understand, etc. So it is continuously updated by our National Remote Sensing Center, and different layers of information it has. In stats, in terms of, you won't find it in Google Map, this much of information for India, but it is an India specific database through which we serve all the ministries. I think this is something which you have to sustain and work on it and to make it very, very public. I think this is something ISRO is banking on now industries to take on, because there is a limit what ISRO can do based on our own infrastructure to make it commercially exploited. And this is something which in my capacity, I would like to explore now, how this Bhuvan Geo portal can be made more public reachable, how it can bring in business for somebody to work on this data and then create some value for customers. So this is something which we look at. And we have been growing this technology in terms of visualization, map creation, user-centric approach. Data analytics are there in the software even today. Those who want to look at some area estimation and things like that can be done to a certain extent, and we want to increase it and also increase the hardware infrastructure, throughput, delivery, etc. in the days to come. And MOSDAQ is another site where who are interested to look at weather and climate, especially meteorological observation, ocean related observation, those who are interested. And there is a lot of information related to these two things. You can go to this site and then understand what all data that we have put in based on the Indian satellite data as well as the foreign satellite data, for those who are desirous of knowing what really happens in the case of snow, the heat waves coming, heavy rains, flooding data, then sea conditions, and all the weather forecast for the entire India is there on the site. Those who please go and then look at this MOSDAQ site for your own benefit. We do not work only on satellite data, so I'm switching the domain quickly because want of time. It is not the satellite data and satellite information related to that we disseminate. We also look at our technologies. I just want to tell you a few of the technologies that we convert for societal benefit. For example, the artificial polyurethane foot that we have successfully handed over to the medical field to create the Jaipur foot. Silica aerogel, which is one of the lightweight insulation material. We also made ventilators of different kinds and handed over to industries which they made, medical oxygen concentrators. We also work on heart valves using the materials and science technology that we have. We also make microcontroller based prosthetic knee joints, which is we work with the medical field to develop and then support. These are some of the offset side, but we also have huge amount of technologies that we have transferred to industries. Almost 400 odd technologies we have transferred to industries for production, supply of products for ISRO program, space program, and other industrial programs. Let me also go into a little bit on the science and exploration, the planetary exploration. I think this must be a well-known topic to you. Already know that Chandrayaan-1 was one of the landmark accomplishment in terms of the success we made to go around the moon and have the first moon probe impacted on the surface. Though it was more of a experimental project, we could get huge amount of data from Chandrayaan-1. As you know today, that Chandrayaan-1 was the one which discovered presence of water molecules on the moon. Though it was an American payload hosted on the satellite, but an Indian payload equivalent also discovered the presence of water. Unfortunately, we couldn't find out initially, but the Americans who discovered it first using the data. But nevertheless, that is one of the important accomplishment of Chandrayaan-1, to achieve such a mission using a low-cost budget and also using PSLV. Chandrayaan-2 was another important landmark mission, though we could go around the moon, but the landing couldn't happen. And we are working on the Chandrayaan-3 specifically for this goal. Mars orbiter mission was hailed as one of the best mission in terms of science exploration, in terms of a nation achieving this in the very first time successfully to place a satellite in the orbit of Mars after traveling almost 300 plus days of travel through space. And the satellite was launched for just 6 months of life, and it worked almost 7 years without any problem. And we are going to bid farewell to that Mars now because it has served the purpose. So we will have to do that. So a decent goodbye we will have to give soon to it. The AstroSat is another important space observatory we have placed. You know Hubble spacecraft, Hubble Space Telescope, and various Chandra Observatory. Though it doesn't belong to that class of observation, but it also has a unique capability which is different from what the Hubble and the Chandra, that it is a multispectral observatory, which is very, very unique. And through this AstroSat, I can tell you why we have found out so many new findings in the formation of stars, explosion of star nebula, the observation of exosolar planets, and you can look at the publication that has come out of AstroSat in terms of the science outcome. It's really fantastic. Aditya L1 is another important mission that we did, going to do. In fact, the satellite is nearly built and completed, and this will go to the Lagrangian point L1 to look at the sun, and using a sun coronagraph understand the sun. And all of you will ask why we have to understand sun. Because the sun is so much connected to our life and the life on earth and the space weather. It is controlled by the sun. The type of ejection, the coronal mass ejection, and the activity that happens in sun really control what happens on earth in terms of the disturbance that will go to the space weather, especially the radiation environment, the interaction with our telecommunication network, and also has a bearing on the global weather as well. So this is an important mission that we want to undertake in the days to come. It's not only that we look at how we can further activities in space missions. We look at EXPOSAT to look at the again at the space. Aditya L1 I mentioned. We have a Mars Orbiter Mission 2 in discussion and currently planning in terms of identification of payload. This is not yet approved. Venus is another important mission where we have done all the groundwork, and we have even proposed, but this is also to be approved in terms of the funding from the government. But here, very important mission, because going to Venus is not the first time that anybody is going. Many people have already gone to Venus, and Venus is very complex planet having a very thick atmosphere and lot of scientific value in terms of exploring and understanding the Venus. Lunar polar exploration is another one where we want to land on the polar part of the moon with a collaboration with Japan, JAXA, and we are working together to develop the satellite. ExoWorld is another satellite in concept currently to look at the exosolar planets, specifically to find out where there is life on other planets other than that in the solar system. So various scientific activities are also taking place while we work on this, and all these are done in budgets which are very, very small. I think this is something, I will skip some slides just for the purpose of my time. I will go to immediately another topic which is very currently relevant, and we have been discussing today what is in store for us in 2047 in space sector. So what I described today are what we did so far, and what way we need to go in the further is something which I would like to discuss in some more slides quickly. If you look at 2047, and 2047, why, you know that another 25 years away from now, and the world will be a different world, and the space sector, the trends that are going to control the space sector are going to be increased private participation. And we look at the economy today, the space sector for the 450 billion will grow to something like 1.5 trillion to sometimes 2 trillion, and people will be traveling to space so frequently, and this is what everybody predicts. And we will be looking at many areas like mining, rare earth metal from extraction. We will be having hospitality and real estate of space, farming in space, etc., etc. But the essential point which I want to drive today, the economy of the space sector today, how big is it? Some 447 billion, and our contribution in that is just 2%, maybe lower than 2%. And this is more driven by the application side. Almost 90% is the application side, the downstream work, and our contribution is still very low. How we can grow it to something like 50% by the time we spend another 25 years down the line? Can India really accomplish to have a space economy contribution to the tune of 50%, which is something like only 1.8% of India's GDP at that time, though it's not a huge number. So it will appear that it is a big task, but it is possible only if you do certain things. I think this is what we like to discuss now. So, what is the economy of 2047 when you grow, and if you are to really become 50% of the global space economy? We need to have a strategy. I think that strategy is that ISRO, whatever we have developed so far, will continue to as a technology enabler, and industries have to come to lead for implementation. So, this is the most important part. And India should become the global space manufacturing hub in terms of the satellites, launch vehicles, or services. Satellite production is something that can be possible happening in India, and I am very sure I am seeing the trends today. There are, as we already discussed, some companies have already set up their manufacturing facility in India for satellite, expecting that orders will come. Have you ever heard of anybody doing such things? And this is happening. Almost 300, 400 crores invested. Some companies have invested and created the facility already for hoping to get satellite building happening in India. And foreign launch vehicles can also be built in India. Why not? And if we can launch it from Sriharikota, it's going to be a business opportunity for us. And Indian non-governmental entities will come out as service and solution providers. And this is the only way that we can actually grow the economy. And what is the net result and benefit that you are going to get? What you see in IT sector boom, we will get exactly the same benefit in terms of the secondary effects that will happen in the industry in terms of job opportunities and all the chains of activities that are required here, including the growth in electronic sector, will really happen, because space is one domain which uses a high-end electronics for you. So the growth target is that today we have only a 14,000 crore economy in space. This is fully funded by government today. But if you really want the economy to grow to a scale where the ISRO has to shrink in terms of a technology provider, and industry has to actually envelop the entire domain in terms of building as well as providing services. Though the substantial growth in the space sector has happening in terms of the number of missions over the years, the numbers are still not very high. Let us know that our competitors, just neighbors, are launching every week one rocket, and they may increase the numbers in the future, and we are nowhere nearby. Unless we act on this, and this type of growth will not happen. I think for this change is really needed, and government cannot fully fund all this activity even if you want to increase to that level, and it has to happen only through a appropriate business intervention. It is not possible otherwise. And that's why the new structures are getting created: the ISRO, the IN-SPACe, the NCIL. These three are coming in addition to Department of Space. Department of Space is umbrella department under which these organizations are coming. ISRO will continue to as a technology center, research happening, new developments happening, looking at the national missions, looking at the requirements for the nation. IN-SPACe is one who will be the regulator and authorizing agents to handle the non-governmental entities to come to space sector, and they will be helped, supported to grow. And NSIL will become the public sector undertaking under which the operational systems of the space sector, the business, will be aggregated, and they will provide the funding which required for the system if they are becoming commercially viable. So this is the plan we have, but the plan requires many more work. I think this is very in simple terms that we put together, but even just for the example of NSIL to become a fund generator, it itself is a big challenge. So we need to find out where there is a market, and for example, launcher market today, they do only market the launch vehicle that ISRO has. That model will not work. They have to find out the market, fund for the launch vehicle production. That production should be supported, and it should be profitable with respect to the global competitive environment. It cannot be protected by us beyond a point. So all these are challenging questions. I think the structure is now created, and we have to find ways by which it will work. So the opportunities, the top part is already explained, so I will only go to the one which is written here. In terms of the business, we look at in the immediate term growing from 15,000 crores to something like 50,000 crores. This I think it in about 10 years of time frame. The operational launch vehicles will move from ISRO to industry totally, like the PSLVs, GSLVs will go to industry, and they will be producing and launching. But ISRO will continue to develop certain technologies, for example, human spaceflight technology, the specific return to launch site technologies, or cost-effective satellite. They will continue to develop, but that will be moved over to the industrial production at later point in time. But I believe that is not the good model. The right model should be industries and ISRO come together to develop new systems. I think this is what we have to do, and we are working on such approaches. So a joint venture of industry, NCIL, ISRO consortium, where ISRO will remain as a knowledge supporter and provider or advisor, industry will be upfront putting the investment to create the new space structures and hardwares, and it can be commercially exploited at later point in time. So this model is something that we should look for. But I believe that if really the economy has to grow, it is not by building rockets and satellites that we are going to grow. It is only by investing in space applications we will grow. As we heard it today in the discussion, that the real share of the economy in space is coming from downline activities in terms of the television and data activities, the ground station and ground support equipments manufacturing, and navigation services. I think this is where the business is, and we need to create industries who are actually working in this domain. They need to be supported if really has to give large scale possibilities for us. And it is very, very clear. I think the industries are also understanding, and I am also seeing the startups who are actually investing in this area are growing faster. They are becoming more successful faster, whereas dwell time for business like building rockets is much longer. The risks are much higher. So but still, I am not telling that is to be disheartened. They need not have to be disheartened. There is some Elon Musk may still come up, but the challenges are much bigger. So we need to have a balance of all this. As far as economy is concerned, we need more of application-centric startups and less of launch vehicle and satellite-centric startups, so that the risks can be mitigated. And this is what I want to tell, not to tell that you should work only in space applications. So the challenge in front of us is that the knowledge that we have in ISRO need to be transferred to industry. See, over the last 50 years, there are certain amount of skills and capability has been developed in ISRO in terms of technology, in terms of designing and making things. But this is not a business model. ISRO is not a business-centric organization. They don't know how to make money, really. But they know how to build rockets, they know how to build satellites, they know how to develop applications. But if you want to really take it to industry, it's a different mindset. And this mindset has to be understood by the department, and we need to engage with this transformation, but not to transfer everything to them and become void here. So it is a constant process of engagement. For you look at the SpaceX, Elon Musk became successful only because he had all the NASA people sitting with him. So it doesn't mean that NASA became weak by that process. So it is to be understood clearly that while supporting the industry, the whole ecosystem is going to grow. The technology within the country will remain, but it's a big challenge. For example, if you want to keep a certain level of expertise within industry, it costs you money. Whereas when you are doing it in government, you can absorb that money. There is nobody ask any question. But if you want to keep that type of expertise there, it becomes a very, very big question. So we need to find out a ways by which the government can sponsor certain amount of knowledge keeping within the organization to support industry, where critical sizes and masses are not possible to be supported by industry. So this is a very difficult question, but this transition of knowledge from ISRO to industry must happen to make them do this. It is already happening. I must tell you that many of our retired colleagues are already mentors of various startups, and they are helping them to go further in the innovative area. The way the new people are doing are entirely different from the way ISRO has been traditionally doing. This is the beauty of it. So the young people have an idea which is totally different from what an organized organization can really create. I think this is the point. And if appropriately mentored by older generation people, it can actually make a strong business case. So let us wait and see how it comes out in next 1 or 2 years of time. And it is happening. I must tell you that startups are there in rocket design, launch services, launch vehicle subsystem development, satellite development. I will tell you an example. I went to IIT Chennai recently. There was a incubation center there. I went to one of the company. I'll say you 5 of them I visited, but the one which is more interesting to me was the Galaxy. They are designing a satellite, small satellite, 125 kilogram, but it has optical and radar simultaneously. They are imaging, and then they are fusing those images together to provide services to customer. And they are planning to build at least 30-40 satellites in that time frame, and they have already made the design. Only 20 people working in a company, startup company incubated in IIT. And they have a history of successfully incubating many companies. One of them is Agnikul. They are already made their first engine ready. So there are many companies who are into this business, and I hope that the ecosystem will grow in the next few years to see fruits of the whole effort. Many of them may fail. I must tell you that many of the startups won't even see the final light. But that is not something that we must be worried about. But some of them will definitely become successful. And that is what is going to be interesting. It is not the case in India. Everybody cannot become successful. but some of them will definitely become. And we must encourage all of them, and to so that the good idea that will withstand the test of time will become successful. And this is what we look at. There are so many industries in India. See, all these startups are facing big challenges. The challenges are, one is the funding. Of course, it's a big issue for all of them. If some startup comes and they need huge funding, space requires a lot of money. You need to invest, and big companies are hesitant to do this. For example, if you look at the big business houses, the return of investment in this whole process is slow. So many of them are reluctant. You need to have high risk business. So at least let them support these small startups to some way, so that they can come together. At least the big houses support these small people. There is a possibility that they may be mentored. It's not mentoring in technology, it's mentoring required in business processes, in terms of finances, risks taking, etc. They need to be mentored. Otherwise, they may collapse. We have 50 big companies who are supporting, having knowledge in this sector, at least 450 of them small and medium, which is there in the space area. And all of them can come together to support this ecosystem. Through that only this will grow. And we believe that it is possible. And I am talking to whoever is there. ISPA is there today, and they will definitely help this understanding within the big industry houses to enable this transition to take place. And it will ultimately help the big houses also. Once it grows to a level, it helps everybody. So I believe the Indian space enterprise is taking shape, and it is actually creating space technology incubation industrial environment. This is specifically that we are looking at. It is not to take place only within ISRO. It has to take place in every place, in academia, in industries, in startups. These new ideas have to take shape. And global space systems like rocket, spacecraft, ground applications are to be delivered from India for the global market. We have been doing launches for small satellites and medium satellites and commercial satellites from India. It's not what I am discussing. We will look at least in the next few years, satellites are built in India, taken to European countries or America, and launched for the use there. I think this is what we are looking at in the near future. And international space industries will start operating from this country. I think this is also our goal, and this will definitely will happen in the days to come. And ISRO has a role to play to become the harbinger of the nurturer of technology for national needs. Very important thing which I didn't discuss is about the strategic requirements. The space is one of the important cornerstones of security and stability for this nation, and this area cannot be ignored. And many nations who are into the business, they have this area handled separately through different funding and different approaches to keep this element very safe. And we need to continue to do that. Of course, we can bring in private industries to support in a great extent, but this requires special attention, because we desire to remain as a strong country. The space sector cannot be ignored at all. I think this need to be supported. So what we look at is big industries, startups, and ISRO together can achieve this transformation. With that, let me conclude and say thank you so much.
Thank you very much, Dr. Somnath, and I think your idea of a space enterprise is really novel, and I'm sure that is what going to work. So thank you very much for this illuminating talk. Thank you very much. Thank you.
Once again, thanks Chairman ISRO and Secretary Department of Space for a beautiful length and breadth, his aspirations, his vision, his view, and what is actually is there and what is going to be there in space domain. Once again, thanks IAS and the respective, let us say, organizers for giving this opportunity for a beautiful session. Tomorrow is the final day for the exhibition. Probably we are going to conclude tomorrow. If whoever is there, you please tell your kids, your family members to visit the exhibition and make it more, let us say, local to global. Thanks a lot. We'll conclude. Thank you.